Good morning.
Good morning. Good morning. I think everybody's in. Good morning, everyone. Good morning. Hope everybody's doing all right. Hope everybody enjoyed the extended weekend. Hold on. Sorry about that. I had a sneeze. So hope everybody's doing great this morning. So let's see. We are looking to get into 1.6, I believe. Of course. If you feel otherwise, let me know. I believe we closed out 1.5 and we're looking to get into 1.6. So 1.6 is called or entitled Other Types of Equations. Where in here, our original equations, 3x to the fourth equal to 27x squared. So what we'll do first is set one side equal to 0. All right, subtract 27x squared to both sides. That puts us here. 3x to the fourth minus 27x squared. And we will look to factor. And so factoring out 3x squared from each term will give us 3x squared times x squared minus 9. And then x squared minus 9 is the difference of squares. So that's what I wrote right here. Don't look good. It was the difference of squares. So the x squared minus 9 breaks down to x plus 3, x minus 3. And then just like before, once you factor completely each part, well, once you factor completely, you can set each part equal to 0 and solve for your solutions. Well, I didn't mention, I wrote it up here. Because our highest power is 4, we should be looking to get 4 solutions, even if it's a repeated one. I'm still holding on to this. So setting 3x squared equal to 0. You would divide both sides by 3. And then you will have x squared equal to 0. Now to get the square off of 0, take the square root of both sides. But don't forget that whenever you take the square root of both sides, you do plus or minus. Remember our square root property. So that would actually be plus or minus 0. And of course, there's no such thing as plus or minus 0. So actually that would be a repeated solution of 0, but you don't have to write it twice. So writing it once is good enough. Here, subtracting 3 from both sides gives you x equal to -3. Adding 3 to both sides here give you x equal to 3. So those are your 3 solutions. And then, like I said, fourth, if you count the repeated solution here for 0. So really it's the same process that we took on when solving quadratic using the zero factor property. You set one side equal to 0, factor as much as possible, and then set each piece equal to 0 and solve. Any questions before we go to the next one? I don't know if I'm scrolling up too far. So the next one is x cubed plus x squared equal to 4x plus 4. And once again, we're going to set one side equals 0. So subtracting 4x and subtracting 4 from both sides cancels 4x and 4 on the right, leaving me with 0. And on the left, x cubed plus x squared minus 4x minus 4 equals 0. All right, any problems? So now we can factor by grouping. You normally use factoring by grouping when you have 4 more terms. So I group together the first two, x cubed and x squared, x cubed plus x squared. And then the second two, notice that the minus sign that is in front of 4x is inside of your grouping. So it's negative 4x minus 4. Factor out the GCF out of each grouping. So I was able to factor out x squared here, was able to factor out negative 4 in the second one. Then pull x squared, not x squared, the common term, common quantity, which is x plus 1 to the front. And that leaves me with what was on the, what was on the outside of x squared and negative 4. So that's why I have x squared minus 4 inside of here.
So you wouldn't like do x plus 1 twice, considering no?
No, it'll be just like this. Let's say if I had x squared y, let me see, what's good? Okay, minus 4y. I would just pull the y out, and that leaves me with x squared minus 4. So it's that same thought process. It's just that this is, instead of y, is x plus 1.
Okay.
Yeah. Good question, good question. It is asked a lot, so. Yep. All right. And then right here, we have a difference of squares that turns into x plus 2, x minus 2. And now that you factor those, factor that completely, set each one of those equal to 0 and solve. X plus 1 equals 0 gives you x minus, well, x equal to negative 1. X plus 2 equal to 0 gives you x equal to negative 2. X minus 2 equal to 0 gives you x equal to 2 as your solutions. Any questions, any questions? Okay. Everybody good before we go to the next one? All right. All right, still in 1.6. This time we're looking at radical equations. So there's a few steps here. So solving radical equations, if necessary, isolate one radical to one side of the equation. Then we're going to raise both sides to the power, both sides of the equation to the power of the index of the radical. So in other words, if it's square root, we're going to raise both sides to, second power, or square both sides. If it's a cube root, we're going to cube both sides and so on. So. Step 3, we want to solve the equation. But if a radical still exists, then we're going to repeat steps 1 and 2. Put it done with step 1. Then step 4, check the solutions, and that's a must when dealing with these type of problems. Not because you may come down and get anything wrong. It's just that even if you do it right, you still could have a solution that does not work, especially when you're dealing with even powers or even roots. And so you'll see what I mean in a second. All right, so let's try this out. Looking at the square root of 2x minus 1 plus 2 equal to x. So I try to make sure that, my plus 2 is not under the radical as far as my writing. All right, so first step is to isolate the radical. So I subtracted 2 from both sides. That gives us the square root of 2x minus 1 equal to x minus 2. All right, so we're dealing with the square root. I need to get the square root off of that x. So I need to square both sides. So the square root and square cancels out on the left, leave me with 2x minus 1. And on the right, I have x minus 2 squared.
So would you, I guess, would the next step be to like factor them together to create your like equation? Like, would you square x minus 2?
Yep. So you say like FOIL it out or expand it. Yep. Let's scroll up. And so we should be good with step 1, I think. Okay. So that's what we're going to do next. The left side is 2x minus 1. So there's nothing we can do with that. But on the right side, we can expand that out. As your classmate suggested, x minus 2 squared is x minus 2 times x minus 2. And you will FOIL that out, give you x squared minus 2x plus 4. Combine your like terms, is minus 4x in the middle. So we will have this. So we have 2x minus 1 equal to x squared minus 4x plus 4. So now, like you see, wrote it in purple, you have to set one side equal to 0. And I'm going to take the 2x and the minus 1 over. So I need to subtract 2x and add 1 to both sides. And that gives me x squared minus 6x plus 5. Excuse me. So if you want, you can put it in the quadratic formula, or you can factor. I'll just go ahead and factor this: x minus 5 and x minus 1. Set each part equal to 0 and solve. X equal to 5, x equal to 1 are our solutions. All right. Any problems? Okay, scroll up. All right, so remember I said the fourth step of check, normally it is an option. You know, if you do everything right, then the answer would be correct and you'd be good to go. But here, in these type of problems, you can do everything right and still have solutions that do not work. And it's because of the nature of what you're doing by squaring both sides and things like that. So you would take your solution. Anybody still holding on to the blue? All right. So you take your solution, x equal to 5, plug it into the original equation. So that's what I did here on the left. So 2 times 5 minus 1 under radical. And then 5 over here for x. So everywhere you see x, you have to put 5. That'll be 9 under radical, which is 3. 9 under radical, and square root of 9 is 3. 3 plus 2 is 5, so that checks out. So on the right side, plugging in 1, 2 times 1 minus 1, that's 2 minus 1, which is 1. Then also we plug in 1 for x over here. So that's 1 plus 2, which will give you 3. 3 is not equal to 1, so that doesn't check out. So this shows that 5 checks and 1 doesn't. So 5 would be your solution, and 1 would just be considered extraneous. All right. Anybody still copying? All right, so we good? Okay. So the next one has more than one radical. Remember, if you look at the steps, it says if a radical still exists, then we need to repeat steps 1 and 2. So here we have a scenario that would do that for us. So we have the square root of 3x plus 1 minus the square root of x plus 4 equal to 1. So the first step is to isolate one of your radicals. Since there's a minus sign sitting in front of this one, I will go ahead and add that to both sides. So this is how we're looking. I added the square root of x plus 4 to both sides. All right. Now I'm dealing with the square root, and I want to get the square root off of 3x plus 1. So I'm going to square both sides. So I have 3x plus 1 now, equal to the square root of x plus 4 plus 1 squared. All right. Just like before, we will expand this right side by folding it out. So don't forget, whenever you're multiplying radicals, you just multiply what's under the radicals. So that for that first multiplication, you have the square root of x plus 4 times the square root of x plus 4. So it's going to be the square root of x plus 4 squared, because x plus 4 times x plus 4 is just x plus 4 squared. Then x plus 4, square root of x plus 4 times 1, it's just square root of x plus 4. 1 times the square root of x plus 4 is just the square root of x plus 4. And then 1 times 1 is just 1. So make sure we're okay with that foiling before we go any further. All right, so in that first expression, first part of your expression, square root of x plus 4 squared, that square and square root will cancel and just leave you with x plus 4. Then we can combine our like terms. Square root of x plus 4 plus the square root of x plus 4 is 2 square root of x plus 4. Because it's just a 1 in front. We want to simplify it further. I can add that 4 and 5. And so our most simplified way of expressing that is right here. 3x plus 1 equal to x plus 2 square root of x plus 4 plus 5. All right. So step 3 tells us that if a radical still exists, and we see that it does right here, then we need to isolate the radical again. So I subtracted x and subtracted 5 from both sides. That gives me 2x minus 4 equal to 2 square root of x plus 4. So now I could have divided everything by 2 because I have this 2 sitting out front, but I'm going to leave it there because just in case that's not the best move for you in other scenarios, I want to emphasize what happens when you square both sides here. We still need to get rid of this square root so we can square both sides. When I do so, on this right side, notice that the square has to affect the radical and the 2 that's sitting out front. Okay, so I'm going to square that 4 and that radical. So I said that 4, that 2 and that radical. So this 2 squared ends up turning into 4. And then that square root goes away. So that's 4 times x plus 4. And then on this left side, you're going to expand that. That's 2x minus 4 squared. So you fold that out. And that'll give you 2x minus 4 times 2x minus 4, which would ultimately be 4x squared minus 16x plus 16. So any questions on either one of those sides before we go any further? As far as squaring them. All right. So we have 4x squared minus 16x plus 16 equal to 4x plus 16. So now we're going to set one side equal to 0. Going to subtract 4x and 16 from both sides. $16 ends up canceling out on both sides. It gives us 4x squared minus 20x equal to 0. Factor. So we can factor out 4x. Then we can set each part equal to 0 and solve. Am I allowed to go up? Anybody still copying that purple? Okay. Did somebody unmute? Did anybody have a question?
No, I was just gonna say that I divided up top. Before you squared it, I divided it by 2, and I got the same exact answers, and it was a lot easier for me. Is that okay if I do that?
Well, yeah, and so I mentioned that. Remember, I said that you could have divided by 2, but I did that just in case there's a scenario in which you wouldn't have that option, because let's say if 3 was sitting out front and now you're making a fraction, you're gonna have to just give an account for squaring the fraction. That's all. So either way. No, go ahead.
No, that's all.
Oh, okay. Yeah. So yeah, either way is fine. I just wanted to give people, make sure this piece. Oh, my eraser was still on. This piece right here, when you square, I just want to make sure that people didn't miss that part, that you got to square those 2 pieces. But most definitely you can divide there and you'll still get the same answers.
Yeah. Okay, thank you.
Hold up. Okay. Sorry guys, trying to get my stuff straight. I made a mistake and erase some stuff. All right, so here we go. Everybody still copying this problem? Can we go to the next one?
Aren't we supposed to check?
Hmm? Yeah, I didn't check this, so that means they probably all worked. Let me see. This is square root.
Because I just checked the 0 and at least if I
Okay,
did it,
there you
the
go.
0 work.
Yeah, you're right. There you go. I have it right there. I thought I was going to the next problem. You're absolutely correct. Thanks. So, like your classmate mentioned, we are supposed to check them. As a matter of fact, if you have an even root, one of them will probably not work. So if you're doing square root, fourth root, and any even root, one of them will probably not work. If you're doing an odd, they should work. So somebody asked me to scroll up a little. I don't know how much you need. That's a little. Is that enough? So plugging in 0. Says, okay, cool. Plugging in 0. When you plug it in, do the calculations, and I'll scroll up in a few. I want to make sure that everybody's in the same spot. Plugging in 0 will not work for us. Plugging in 5 will. And we should be good. Should be good. All right, can I scroll up? Any questions? Any questions? All right, let's scroll up. Everybody good? And I'm still holding on to the purple. All right, next type of scenario we could come across is having a fraction as your exponent. So we have a radical equation of the form of x to the m over n power equal to k. So notice it says the first condition if m is even. So we're talking about that numerator of our exponent. If m is even. So notice the way we'll solve is by applying the reciprocal as a power to each side so that these will cancel out on our variable. And when we put numbers on it, pretty sure it'll look better. But if m is even, that numerator is even, you have to do plus or minus. Goes back to our square root property. And then if m is odd, then we just apply it as normal. You're only going to get one solution. All right. So just to emphasize the relationship before we do the solving, just want to show you how this works. Everybody done with that? Can I scroll up a little? Okay. So if you have 8 to the 2/3 power, the numerator is always your power. The denominator is always your root. So it doesn't matter which order you apply them in. As long as you hold true to that, then you're okay. So you can do the cube root of 8 squared, or you can you can take the cube root of 8 and then square it, or you can square 8 and take the cube root of it. As long as, once again, the denominator is your root, numerator is your power, you're still going to get the same answer. So if you take the cube root of 8, that's going to be 2. 2 squared is 4. But if you square 8 first, that's 64. Then the cube root of 64 is still 4. So like I said, it doesn't matter which order you apply them, as long as you hold true to the fact that the denominator will be your root, your numerator will be the power. All right. All right, so let's look at the first equation with this type of scenario. We have 3x raised to the 3/4 power minus 81 equal to 0. All right, so we want to isolate this x because that's what's being raised to the 3/4 power. Notice that m is odd, so that means we're only going to have one solution. So we add 81 to both sides. That gives us 3x to the 3/4 equal to 81. Divide by 3. That gives us x to the 3/4 power equal to 27. Then we'll raise both sides to the 4/3 power. So we're going to flip that fraction. Flip this fraction and apply it to both sides. So we have 3/4, so we apply the 4/3 power to both sides. All right. And right here, just showing you what happens and why we do that. 3/4 times 4/3 will simplify to 1. So that'll give us x to the first power, which is what we need, just x. But then we have 27 to the 4/3 power. So now that 3 is the radical. Take the cube root of 27, which is 3. Then 3 to the 4th power is 81. So our solution is 81.
So I remember in like school doing the 3 inside like the little swoop of the radical, but I don't remember like, obviously you could just do that on a calculator, right? And it would like work. Okay.
Was that a question or like, you didn't really have anything?
I don't even know what my question is. Give me a minute.
Okay. So maybe this will help. So whenever you're looking at the cube root of a number, you're asking yourself what times itself 3 times will give me that number under the radical. So it was 3 because 3 times 3 times 3 gives me 27. And then here, we're raising it to the power. So we multiply 3 times itself 4 times. That's how we got to 81. So.
Okay, that makes more sense. Thank you.
Okay. Okay, cool. All right. All right. Any questions on that one before we look at another one? All right. So here we have x to the 2/3 power. Let me erase this. So we have x to the 2/3 power minus 3/4 equal to -1/2. So once again, we want to isolate x to the 2/3 power because that's the only thing being applied to by the 2/3 power. We want to solve for x. So we're going to add 3/4 to both sides. So adding those fractions will result in 1/4. Now, in order to get the 2/3 power off of x, we need to raise both sides to the 3/2. Remember, we just flipping the fraction and applying that power to both sides. Now, because remember our numerator or our exponent was even, when we flip it, that means that's going to be on the denominator now. So that means it's going to be the square root. So that's why you have to do the plus or minus. This is going to give us two solutions. So we do plus or minus square root of 1/4 cubed. Square root of 1/4 is 1/2. Cubing 1/2 is 1/8. So we got plus or minus 1/8. You don't need what's over here in the purple. I think somebody asked me something about signs, so I was just doing that. All right. Questions? Any questions?
So then where did the like 2 go for the exponent?
Right here for the square root.
Oh, okay.
Mm-hmm. All right. Got this one. I think this is the absolute value. We may finish, may not. We'll see. All right. So let's look at, here we go, equations in quadratic form. So we have x to the 4th minus 8x squared minus 9 equal to 0. So whenever you have an equation, when you look at this second term and comparing it to the first term, it's that term squared. So in other words, when we look at what I have here in the purple, I have x squared right here, but then x to the 4th is x squared squared. That's considered being in quadratic form. So it's just like this type of setup where that second term, the second term is being squared in the first term as far as your variables are concerned. All right. So if you ever have that scenario, once again, we look at this, I have x squared, and then here x to the 4th is x squared squared. You can either try to, solve it in that form, but recognize you have quadratic form, or you can do what we call U substitution in order to make things look a little simpler for us. If we decide to let U be equal to x squared, you recognize now we have a regular quadratic equation. That's U squared minus 8U minus 9. So once again, we just put U where we saw x squared. Now we can factor that, or if you wanted to do the quadratic formula, you could. But that factors the U minus 9 and U plus 1. Set each part equal to 0 to solve. U is equal to 9 and U is equal to -1. All right. So we're not finished though, because remember we started off with x squared, not with U. So we can plug the x squared back in once we solve for U. Just give you guys a chance to write. So now we have x squared equal to 9, x squared equal to -1. All right. Take the square root of both sides. Don't forget your square root property. And you have the four solutions, plus or minus 3 and plus or minus I. All right. Questions on that? All right. Next one, we have a similar scenario. Once again, we have an equation in quadratic form. Here we have 5x to the 2/3 power plus 11x to the 1/3 plus 2 equal to 0. So we have x to the 1/3 in our second term, and our leading coefficient is 2/3. Well, that's actually 2 times 1/3, or 1/3 raised to the second power. So we can let U be equal to x to the 1/3. So that'll give us 5U squared plus 11U plus 2 after we do our substitution. Once again, I decided to factor, but if you want it, you can use the quadratic formula. So it factors out to 5U plus 1, U plus 2. Set each part equal to 0. And solve, you have U equal to -1/5, U equal to -2. Then put your x to the 1/3 back into your equation for you. So here in the purple circle, I was emphasizing the fact that x to the 1/3 is the same thing as the cube root of x. So if you have the cube root of x and you want to get that cube root off of x, you will cube both sides. In other words, raise both sides to the 3rd power. So that's what we did in order to solve. We have x to the 1/3 equal to -1/5. We cube both sides. That gives us x to the -1 over 125. Then we have x to the 1/3 equal to -2. Cube both sides. That would be x equal to -8. All right. Any questions? All right. Can I scroll up? Oh, hold on 1 second. Absolute value. Let's see what's 1.7. We can try to do it. Let's see. All right, so let's look at absolute value equation. Last thing before we close out. So we have the absolute value of 2x minus 3 equal to 11, and we want to solve that. So the way we'll solve the absolute value equations says if we have the absolute value of u equal to c, we will set u equal to c and then set u equal to -c in order to solve for it. So you're going to have 2 answers. All right. So we take 2x minus 3, set it equal to 11, and 2x minus 3 set it equal to -11. Because you want to give an account for when it's 11 and when it's a -11, because the absolute value of 11 is 11. Absolute value of -11 is also 11. So you have to give an account for when it is either. So that's why you're getting 2 answers here. All right. So go ahead and add 3 to both sides. (2x equal to 14 and 2x equal to -4, -8, excuse me. Divide by 2. X is equal to 7 and x is equal to -4. Any problems before we do another one?
So whenever we're doing these problems, we're always going to have, like, once we get like the absolute value alone, we're always going to have to set it one answer to positive and one answer to negative.
Yep.
Okay.
Mm-hmm. And so she said something very key there. Once you get the absolute value alone, and that's what the first step is here. Want to isolate the absolute value. So you don't do what we just did with that last one unless you have your absolute value on one side of the equation by itself. Yep. So we add 15 to both sides and then divide by 5. Is everybody done with the last problem? So once again, adding 15 to both sides, then dividing by 5. Absolute value of 1 minus 4x is equal to 3. Then you set each part, I won't say each part, set it equal to the positive 3 and then set it equal to the negative 3. So you would originally have this 1 minus 4x equal to 3, 1 minus 4x equal to negative 3. Then subtract 1 from both sides. In each case, that'll give us 4x equal to 2, but negative 4x equal to 2, and then negative 4x equal to negative 4. Then divide by negative 4. And that'll give us a solution of x equal to negative 1/2 and x equal to positive 1. All right. Questions before we look at the last one? All right, so last one, absolute value of 3x minus 7 equal to negative 21. So we want to be careful here. If you were to ask yourself, remember when you're talking about solving an equation, you want to know, when is this equation true? What value of x can you plug into the equation to make it true? So you also can ask yourself, since we're dealing with absolute value, when is the absolute value of 3x minus 7 equal to negative 21? Well, the answer is never. And that's because the absolute value of a number is never negative. So don't forget, whenever you take an absolute value of something, the result will always be positive. So if after you isolated your absolute value, notice that is key here. Absolute value has been isolated already. We have the absolute value of 3x minus 7 equal to. If it's equal to a negative value, the answer is no solution. All right, any questions on that? Questions. Some questions may not show up until you start working on it. So, but that's 1.6. Next class, we'll look to get into 1.7 and go from there. Any questions? Yep, thank you. Any questions before we close out? Everybody good?
Mr. Tucker, I apologize. I was late. Is it possible for me to take a quick picture of the beginning of the notes?
Sure.
So I have what I need for homework.
Yep, not a problem. Is everybody done copying before I scroll up? Everybody good? All right, so if you guys are good, I'm good. I'm gonna our class is over. I'm gonna go ahead and scroll up for her, and I'll see you on next class.
Have a great day, Mr. Tucker.
Thanks, you do the same. Take care. Bailey, all right, take care, Bailey, I will email you shortly. I'll email you that shortly.
Okay, sounds good. I'll see you then. Thank you.
All right, no problem, take care.
I have everything below, I guess it was the first section, 3x minus 27x equals 0.
I forgot you talking, yeah, I forgot we started here. All right.
Okay, and then just a little bit more, I think. Okay, I got that.
Okay, I think it was a little bit more under here. All right, did you have the next one? This one right here?
I do not think so.
Okay, all right.
Actually, Mr. Tucker, I might have that one.
Okay.
Yeah, I do. I have that
Okay.
one.
Okay, so it was only the first one you missed. Okay.
Thank you so much.
Not a problem. You have a good one.
Thank you, you too.
All right, everybody, take care.